All right, let's look at our semester exam review. We're going to do the even, so we'll start with number 2. Okay, we're looking at the absolute value equations. What we need to do is we need to set up our two cases. Our first case is our positive case, so we got 2, absolute value of 4 minus 7x. So I'm going to go ahead and distribute this puppy in. 8 minus 14x on this side equals 7x plus 6. Okay, we also have our second case, which is the negative, right? So we're going to have the same thing on this side, 8 minus 14x. But on the other side, we have negative 7x minus 6. That's my negative case. We can take the negative of the entire side. All right, so now we're solving for x. So we're going to get our x's on the same side. So let's add 14x over here. We get 21x. Let's subtract 6 to this side. And we get 2 equals 21x, so x equals 21 over 2. My other case, okay, and same thing, we're going to add 14x to this side. We get positive 7x. Let's add 6 to this side. We get 14. So 14 equals 7x, so x equals 2. All right, let's go on to number 4. Is an absolute value inequality. We do the same thing. We're going to set up our two cases. So I've got 4x plus 8. My positive case is less than or equal to 24. Oh, and I got my other one. So and 4x plus 8 is, flip your sign, greater than or equal to, and a negative 24. So my negative case, we need to flip our sign and make the other side negative. We're going to do the same exact thing. We're going to solve for x, so let's subtract 8 on both sides. And we get 4x is less than or equal to 16, so x is less than or equal to 4. And my other case, subtract 8 on both sides. So we get x is greater than or equal to negative 8. All right, so we can see that x is less than or equal to 4, and x is greater than or equal to negative 8. All right, so on the number line, my solutions will be from negative 8. X is greater than that, but it's less than 4, so my solutions are in between 4 and 8. Looking at number 6. Number 6, we're going to find the domain range of the absolute value function. So we've got the absolute value of x plus 3 plus 2. All right, so now what transformations took place? We had a horizontal transformation, a horizontal translation, Left 3. It's inside the absolute value, okay, and it's a positive. That means we plugged in a negative to make that a positive 3, so it's a negative 3. So we shifted left 3 units, but we also shifted it up 2 units. So we translated up 2 units. So the vertex of my parabola is negative 3, positive 2. We know it's a positive parabola. Positive absolute value. Okay, so it would look like that. Okay, so from that graph, my domain is all real numbers, right? From negative infinity to positive infinity. My range, however, is not. Okay, the lowest point on the graph is right here at my vertex, which is at positive 2. And it goes to infinity. Okay, we could also say that y is greater than or equal to 2. Let's go to number 8. Okay, number 8 says a pet shop has a self-service food counter. The counter has a minimum of 40 pounds of dog food and a maximum of 60 pounds of dog food. What is the absolute value inequality that represents the amount of dog food that the store has at any given time? Okay, so we have a minimum and we have a maximum, right? So we know that my dog food needs to be between 40 and 60. All right, so now what I'm going to do, okay, the difference being between these two numbers is a difference of 10. Between these two numbers is a difference of 10. So the absolute value of x minus 50, okay, the absolute value of this needs to be less than or equal to 10. right, let's go on to number 10. All right, number 10, we want to graph that absolute value inequality. So we have y equals the absolute value of x plus 6. So again, going back to just like we did on number 6, I plugged in a negative 6 for my x value, okay, for my vertex. My y value is 0 because we did not have a vertical translation. So what that would look like is that puppy right there. All right, let's go on to number 12. Number 12 says, which of the following describes the translation of y equals the absolute value of x to y equals the absolute value of x plus 7 minus 2. All right, so we've got the parent function, and we've got y equals the absolute value of x plus 7 minus 2. So what changed? We have a horizontal translation, and we have a vertical translation. So we went left 7 units, and we went down 2 units. Okay, so left 7 units and down 2 units would be answer choice B. Rocking on to number 14. Okay, number 14, we want to compare each function with the parent function. We're going to look at the vertex, axis of symmetry, and the transformations. So number 14, we have y equals the absolute value of negative 7x plus 6 plus 6. All right, so we know we have 3 transformations here. Actually, excuse me, 4 transformations here. We have 1, 2, 3, and 4. All right, so the first one is a reflection over the x-axis. So it's going to open upside down now. It's going to open downward. Okay, the second one is a horizontal compression. Third one is a horizontal translation, just like we've been talking about. And we're going left because it's a positive, so left 6. And then a vertical translation, up 6. So those are my 4 different transformations for number 14. So with that being said, number 16, okay, I'll write it right here. Number 16 is y equals the absolute value of negative 2x plus 4 plus 4. Okay, we have the same 4 transformations. We have a reflection, we have a horizontal compression, we have a horizontal translation, and we have a vertical translation. Just the numbers are different, but the same 4 transformations apply. All right, going on to number 18. Number 18, you have your graph. Okay, it says what's the equation of the absolute value function graphed? All right, so let's look at our vertex. Okay, our vertex is right here at negative 8, negative 5. So we know that we have x plus 8 inside the absolute value, and we have minus 5 outside the absolute value. So if I'm looking at my answer choices, oh, that's a 6. Yes, sorry, my fault, not 5, it's 6. Between 4 and 8. Hello. X plus 8 and minus 6. X plus 8 and minus 6. So you're choosing between A and D. Oh, you can't even see that. All right, here we go. Okay, so it's x plus 8. We know that we went left 8 units, so that is the correct translation horizontally. Okay, we both went down 6 units, so we're choosing between A and D. Now we need to figure out, is it opening upward or downward? It's opening downward, so it's a negative, a reflection across the x-axis. D has to be your answer. All right, number 20, it says, what are the solutions of the following system? So let me write that pupper down. All right, so you have your system of equations. You can solve it however you want to. You can solve by substitution, graphing, or elimination. If it's me, I'm solving this by elimination. Okay, these are already set up to eliminate. You need the same number, different sign to be able to eliminate, because you're going to add these two expressions together. So if I have a positive x and a negative x, those are eliminated or cancel out. If I have a positive 3y and a negative 3y, oh my goodness, those are also eliminated. So over here you've got 0. Over here you've got 8 minus 8. That's also 0. Does 0 equal 0? Absolutely. So what are the solutions to that system of equations? The solution is infinite. Many. Because whatever you plug in is still going to be 0 equals 0. So infinite many solutions.